All right, this video is part 2 of section 13.1, dealing with properties of polygons using coordinate geometry. So here I'm going to pick up with the distance formula and the standard equation of a circle. Okay. So here, a circle has the center of A, which is going to be the ordered pair H, K, and a radius of R. So here, the center is H, comma, K, and then this distance from the center to a point on the circle is called the radius R. And let's say I want to verify that all points B, which is X, comma, Y, on the circle satisfy the equation X minus H quantity squared plus Y minus K quantity squared is equal to R squared. Okay. So in this case here, this is where they use the distance formula to come up with that. So here, B is going to be X, comma, Y. That represents any point on the circle with center A, which is H, comma, K. So that means that every point B on the circle satisfies the equation B, A equals to R. That's the distance from B to A, equaling to the radius, which is R. And then if we apply that distance formula, you'll get the following. In this case here, the distance from B to A would be that's the square root of X minus H quantity squared plus Y minus K quantity squared. Okay. X minus H and then Y minus K. Each difference would be squared. And then if you square both sides to eliminate the square root, this is what you'll get. X minus H quantity squared plus Y minus K quantity squared equals R squared. And that would be the the formula or the standard equation of a circle. So here it is. The standard equation of a circle with center H, comma, K and radius R units is this: X minus H quantity squared plus Y minus K quantity squared equals R squared. Let's look at problem number 5 on page 795 in your text. Write the standard form of the equation of the circle shown. Okay, the first thing we need to do here is this. I can see that the center is at A, which has the ordered pair 4, 3. There is a point on the circle, which is B. That ordered pair is, negative 1, 5. The problem is we don't know what the radius is. That's the distance from this point to that point. So let me draw a line. Okay. So from here to here, that's your radius. So to find the radius or the distance from the center to a point on that circle, we use the distance formula. And that's D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1. And that quantity will be squared. So here we're going to have the square root of, let's see, x2 minus x1. This would be 4 minus a negative 1. And that's squared. Plus y2 minus y1, 3 minus 5. And that quantity will be squared as well. All right, so next step would be, let's do 4 minus a negative 1. That's going to be 5. this will still be under the square root. 4 minus a negative 1 would be 5, and that's squared. Plus 3 minus 5 would be negative 2. And that 2 is going to be squared. If I square the 5, that will be 25. Plus negative 2, you square that, negative 2 times negative 2, that will be 4. And then 25 plus 4 would be 29. So my distance will be the square root of 29. And I'm going to leave that as is, because that distance is also going to be the radius of that circle. That's the square root of 29. And I know what the center is. That's going to be the ordered pair 4, 3. So that means H will be 4 and K would be 3. And the standard form for the equation of a circle is this: x minus h quantity squared plus y minus k quantity squared, and that's equal to r squared. Now my equation has to have the x and y in it. So this will be x minus, this h in this case is the x coordinate of the center, which is 4. So it'll be x minus 4 quantity squared plus y minus k in this case will be 3. So I got y minus 3 quantity squared. And that's equal to r is the square root of 29. But that has to be squared. Now if I take the square root of 29 and I square it, I will get 29. So the standard form would be x minus 4 quantity squared plus y minus 3 quantity squared is equal to just 29. That would be the standard form for the equation of that circle. Okay. All right, now we're going to look at similarity, distance formula, and midpoint formula as well. Here we want to derive a formula for the coordinates of the midpoint, which is called M, of the line segment that joins points A, which is x1, y1, and B, which is x2, y2, as shown here. Because here we got A and B, and the midpoint is right here. We want to find out what would be the midpoint of a line segment if you have the two endpoints. So the point Q is the intersection of the horizontal line segment through A and the vertical line segment through B, as shown here. So here's point Q right here. What they did here was they drew a vertical line through B and a horizontal line through A to form a right triangle. And then next, we see that Q has the coordinates x2, y1, and triangle ABQ is a right triangle. So here's ABQ right here. That is a right triangle. And Q has the coordinates x2, y1. The distance AB between A and B is the length of the hypotenuse. So here, A to B, that's your hypotenuse in that right triangle. So here we're going to draw a perpendicular line segment from M to AQ, right here, as you can see here. And they're labeling that as MP, as that line segment. So the point P is going to be the intersection of those two line segments here. And that's going to create two right triangles, where triangle AMP and triangle ABQ. Then that means that triangle AMP is similar to triangle ABQ by what they call the angle similarity axiom. So Probably somewhere in the second part of math for teachers, you learned something about similar triangles here. That means that AM is to AB as AP is to AQ and as MP is to BQ. And that's because the ratio of corresponding sides is identical. Okay. Now, because AM to AB is going to be equal to 1/2 by definition of the midpoint, AM to AB will be 1/2. That's equal to AP over AQ equaling to MP over BQ. And then next, each ratio does equal to 1/2, so that means that AP over AQ is 1/2, and MP over BQ is also equal to 1/2 as well. Okay, now, they did a little substitution here. The distance from A to P was x of M minus x1 over x2 minus x1. And then 1/2 for the MP, they did ym minus y1 divided by y2 minus y1, using the distance here. And then they solved for x of M and y sub M to come up with these two values here. The x-coordinate of the midpoint would be x1 plus x2 divided by 2. The y-coordinate of the midpoint would be y1 plus y2 divided by 2. Okay, that's how they come up with the midpoint formula. Not something that you have to be responsible for on an exam, but this is it. But do know what this midpoint formula is. The midpoint, which is M, with the coordinates xm, ym, and of a line segment that joins A, which is x1, y1, and B, x2, y2, has the x-coordinate as x of M equaling to x1 plus x2 divided by 2, and y-coordinate would be y sub M equaling to y1 plus y2 divided by 2. So basically, you're just taking the average of the two points, but the average of your x-coordinates and the average of your y-coordinates. Okay, now this next slide I'm going to show you has something to do with how to apply the midpoint formula. Find the equation of the perpendicular bisector of the line segment joining A, which is negative 6, 1, and B, 2, 4. Now, the definition of a perpendicular bisector. Let's say you had a line segment like this. Then the perpendicular bisector is going to be that line that bisects the line segment into two equal parts. So the midpoint will have to be somewhere right here. That's the midpoint. And this line is your perpendicular bisector, because it forms a right angle and it passes through the midpoint of the line segment. That's what we mean by a perpendicular bisector. So here the perpendicular bisector passes through the midpoint of AB and has a slope that is the negative reciprocal of the slope AB. So if we know what the slope is for line segment for line AB, then the perpendicular line will have to have a slope that is a negative reciprocal of that. So first of all, we find the midpoint. So for the x-coordinate, we add negative 6 and 2. Those are the sum of the two x-coordinates here. Negative 6 plus 2, x1 plus x2, that's negative 4 divided by 2 will give you negative 2. And then the y-coordinate, we add the two y-coordinates of A and B, 1 plus 4. That would be 5. 5 divided by 2 would be 5/2. So the midpoint would be the ordered pair, negative 2 and 5/2. There's also something else we need to know. We need to know the slope of that line segment AB. That's where we have to use this formula. M is equal to y2 minus y1 divided by x2 minus x1. You have to know what that is to find the slope. So here, rise over run, y2 minus y1, that was 4 minus 1, divided by x2 minus x1, that's 2 minus negative 6. So 4 minus 1 would be 3, and then 2 minus a negative 6 would be like 2 plus 6, which is 8. So the slope there would be 3/8 for the line segment AB. And then if we want the slope of the perpendicular bisector, we take the negative reciprocal of AB. That slope was 3/8, so the negative reciprocal would be negative 8 over 3. And then we use y equal mx plus b. And we can use either one of those points. Okay, well, actually, we have to use the midpoint, which is -2 and 5/2. Yeah, because we have to use the midpoint because that midpoint is that point that's on the perpendicular bisector. So we have to use that along with the slope of -8/3. Okay. Now, when they did the algebra, they came up with b is equal to -17 over 6. So that means the equation of the perpendicular bisector is y equal -8/3 x minus 17 over 6. Okay, now let's look at problem number 30 on page 796. All we're going to do here is just determine the midpoint of the line segment with the endpoints A and B. So in part A, we got A, which is 4, -2, and B, which is 7, -6. So if I want to find the midpoint here, x sub m, that would be x1 plus x2 divided by 2. The sum of the two x coordinates for A and B. And I'll divide by 2. So here, the x coordinate of A is 4, plus the x coordinate for B, that's 7, divided by 2. So 4 plus 7 is 11, and I'll leave that as 11/2. And then I need the y coordinate as well for that line segment AB. So y m, that'd be y1 plus y2 divided by 2. So y1 is -2 plus y2, that's -6. That sum will be divided by 2. So here -2 plus -6 is -8. -8 divided by 2 is -4. So the midpoint for line segment AB in part A would be 11/2 -4. Okay. Now for part B, -6, 2 for A and B for 3. Okay, so I'm going to use these same two formulas here to find the midpoint. So the x coordinate of the midpoint would be this, -6 plus 4. That's the sum of your x coordinates here. And that's going to be divided by 2. -6 plus 4 would be -2. And -2 divided by 2 is -1. And then the y coordinate of that midpoint would be this, 2 plus 3, x1 plus x2. x1 is 2, y2 is, y1 is 2, and y2 is 3. So it's 2 plus 3 divided by 2. 2 plus 3 will be 5. And we just leave that as 5 halves. So that midpoint would be -1, 5 halves. Okay, now this example is similar to the one that I went over, but let's go ahead and talk about this one. Find the equation of the line that is the perpendicular bisector of AB with the endpoints A being the ordered pair of 7, 3, and B being the ordered pair of 4, -1. And this is problem 25 on page 796. So the first thing I need to do there is find the midpoint of AB. So that means here I need the x-coordinate of the midpoint. That's going to be x1 plus x2, 7 plus 4, divided by 2. And that's going to be 11 halves. And the y-coordinate of the midpoint, that's y1 plus y2, 3 plus -1, divided by 2. So 3 plus -1 would be 2. 2 divided by 2 would be 1. So the midpoint would be the ordered pair, 11 halves and 1. That's the midpoint of AB. There's also something else I need to find. The slope of that line segment going through those 2 points. The slope formula is that y2 minus y1 all divided by x2 minus x1. That's the next thing I need to find. So here, y2 minus y1 will be -1 minus 3 divided by x2 minus x1, 4 minus 7. Let me see. -1 minus 3 is -4. 4 minus 7 is -3. Well, if I divide negative by negative, that's going to be a positive 4/3. So that's the slope of that line going through those 2 points. Now, it says perpendicular bisector, so I need to find out what the slope is for that perpendicular bisector. I only found the slope of the line AB, that's 4/3. So for the perpendicular bisector or the perpendicular slope, I take the negative reciprocal of that. So this is 4/3 is positive, so I change it to a negative and flip 4/3 over to 3/4. So now to get the equation, I'm going to use the perpendicular slope of -3/4 and the midpoint 11 halves and 1. I have to use that midpoint because the perpendicular bisector, that's the line going through the midpoint. And the midpoint is 11 halves and 1. And this is where we use y equal mx plus b to find out what the b is, or the y-intercept. The y-coordinate there is 1, so y is equal to 1, equals to the slope, which is 3/4, times the x-coordinate of that midpoint, that's 11 halves, plus b. Now, if I do 3/4 times 11 halves, this will be 33/8, and then plus b. And then to get b by itself, I need to subtract 33/8 on both sides. So the b in this case would be, and I'm going to cheat with my calculator. in this case here, clear that out. I'm going to do 1 minus, and in parentheses, 33 divided by 8, and then close the parentheses. There's a button that says the math key. I'm going to press that, and then fraction. This will give me a negative 25 over 8. That will be the y-intercept. Or do this. 1 whole would be 8 over 8. 8 minus 33 would be negative 25, and then you bring over the denominator of 8. So the y-intercept is negative 25 eighths. So that means the equation of that line, which is the perpendicular bisector of line segment AB, will be this. Y is equal to the perpendicular slope of negative 3/4. That would be multiplied by x. And since that's a negative 25 eighths, it'll be minus 25 eighths. That's going to be the equation of the line that is the perpendicular bisector of line segment AB. Okay, so that will complete this video on the properties of polygons using coordinate geometry. And that homework will be available for you on WebAssign for you to complete. Make sure, well, please feel free to email me if you have any questions or concerns about the homework.